Good evening, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Hi, I'm Scott Charolais. I'm going to be your host today, and I'm also here with my co-host, as usual, Dr. Clay Zimmerman. Clay, welcome.
Thanks, Scott. What's in your glass today?
We got water today, Clay. We
have
have water
water.
today. It's going to be a long day. And kind of the context behind that is that we are at the Florida Ruminant Nutrition Symposium this week, and we're going to be recording 7 podcast episodes from presentations being presented this week. So we are starting rather early here in Florida. So water is on tap, and Clay wouldn't be able to drink for all of these we're going to be recording today. So they may get interesting, but we're just not going to go there. Yeah. We have a featured guest with us today. That's Dr. Tara Felix from Penn State University. Should I say we are?
You should. Penn State.
Absolutely. I think we all know that I went to Ohio State, and the gals know that I will mention it once during every episode. But
Well, then should I say OH?
I-O. Absolutely. Now, I had 2 sons that went to Penn State, so very accustomed to that and spent a lot more money at Penn State than I ever did at Ohio State. So,
Most people do.
yep. So Tara has given a presentation this week here at the Florida conference titled How Beef on Dairy Selection Impacts Beef on Dairy Production. Now, this is going to be the first of 3 episodes that we're going to be recording here at the Florida Nutrition Conference on beef on dairy. So you're going to want to stay and listen to all 3 of them, and we're going to be releasing those over a period of about 3 weeks. So Tara, welcome. This is your first time at the Real Science Exchange, although you have given a lecture for us on the Real Science Lecture Series, and you can find that, folks, at balchem.com/realscience. So Tara, welcome, and would you mind just kind of telling us a little bit about yourself?
Yeah, well, first.
The economics of feeding Reassure precision release choline. Reassure is fed during the transition period, and because it's fed for such a short period of time, it costs just $15 per cow, and yet the benefits will continue to generate income throughout the year. Cows fed Reassure produce 5 pounds more colostrum, which pays for your Reassure investment on the very first day of lactation. Cows fed Reassure also produce 5 pounds more milk per day, every day. That means after the first day, every day is payday. Invest in Reassure during the transition period and recoup your investment on the very first day of lactation. After that, you got it, payday.
First of all, Scott, thanks for having me. Florida is actually one of my many alma maters, and so it's great to be back this week. I grew up in Pennsylvania and got my bachelor's degree as well at Penn State. Came down to Florida for a master's degree with Dr. Lee McDowell, and then did a PhD at Ohio State. So got all the connections there today with Dr. Steve Lurch. I was on faculty at University of Illinois for a little while when Terry Etherton called me and said, "Hey, we've got a job at Penn State. Would you like to come back home?" And I said, "Well, there's just about as many beef cattle in Pennsylvania as there is in Illinois, so sure, why not?" and part of that exchange was now I get to do a lot of extension work, and that's really my pride and joy is working with the beef cattle producers every day.
Looking forward to the podcast today and learning. We also have a special guest with us, Dr. Brad Johnson. Brad, welcome. This is also your first time at the Real Science Exchange.
Absolutely. I appreciate the opportunity, Scott. So,
very welcome. Would you mind just kind of giving us a little bit of background on yourself?
Sure. I have no connections to any of these universities that have been aforementioned, but I grew up in South Dakota and did my undergrad at South Dakota State University, and then did both my master's and PhD at the University of Minnesota in a very basic, I grew up on a feedlot in South Dakota, so I've been around feedlot production my whole life, but the research I did for my dissertation at the University of Minnesota was very basic muscle biology, muscle growth research, and looking at how growth promotants that we use in the feedlot industry every day impact that. So that I've kind of maintained that theme of research throughout my entire career, but I did the complete opposite of what Tara did. I went back home right after my PhD. I was on faculty at South Dakota State for 3.5 years in a that was an extension position as well, very applied research. But because of my passion for basic muscle growth research, Kansas State had never had a basic scientist on the muscle biology side. So I was in Manhattan at K-State for 8 years, from 2000 to 2008, and predominantly a research role, but did teach fundamentals of nutrition and had some great students along the way there, and had no reason to leave Manhattan. Our family loved, kids grew up there. My youngest son was born in Manhattan, but Texas Tech had an endowed chair position. And I've been in the Gordon W. Davis Regents Chair position now for 17 years at Texas Tech, but really still doing the same work that I did at K-State, and still have a teaching role as well.
Ah, good deal. You mentioned muscle biology, and I'll go ahead and mention that you're also giving a presentation here at the Florida Conference, and we'll be doing an episode on muscle biology, and it's quite fascinating. You and I rode from the airport last night, and we should have recorded that session. That was very interesting, but we'll have to try to recreate that here this week. Tara, why don't we just jump in and kind of give us an overview of what your presentation is going to be about later today?
Well, when I started at Penn State, Scott, I came on, and before I even got there, I had a call from the extension agents there, and they said, we have 2 major packers in the state, and one of them is really interested in Holstein calves. So I started at Penn State in 2017. They said, or 2016, excuse me. They said, we really want to know how to add value to these Holstein calves. They're coming in, they don't have much muscling. We want you to do an extension demonstration your first year here. So fast forward to 2017, when Holstein calves took a nosedive in the marketplace, right? And I had all the producers calling me, Felix, you're telling us we got to do these Holstein calves, and I just paid the auctioneer $6 to take them for me. And so I transitioned fairly quickly then into beef on dairy, and I've been researching the beef on dairy cattle and the feedlot systems for the last 5-6 years now. Today, I'm going to steal shamelessly from a brilliant PhD student that I had for my presentation. She actually got her master's in dairy cattle genetics, Dr. Bailey Basile. She's working on a postdoc right now with USDA. Got her master's in dairy cattle genetics, and then during COVID, I got a USDA CARE grant, which is a critical agricultural research and extension grant, where we try and marry the research that we're doing at universities and get it out quickly so that it can be applied for our producers. So it was 2020 when I got that grant, and the university just said, well, you're not recruiting graduate students right now. We're not doing live animal trials. This is all a big trauma, right? So Dr. Basile was there doing her master's degree, and I talked to her master's advisor, and I said, how good is this kid? And he said, oh, she's good. She's real good. So presentation today stems from the fact that she had this interest in dairy. And so when she wrote her PhD dissertation, it was very unlike most dissertations in that it very deep and singularly focused. She wrote a chapter on how beef on dairy impacts the dairy systems. She wrote a chapter on how beef on dairy impacts the feedlot systems. And then she followed up with a final chapter that'll be published this spring on the genetic components of those crosses.
Oh, interesting. So can you tell me, starting off, what are the differences you see in raising just pure dairy calves versus these crossed up calves?
So when we first switched to beef on dairy, the very first year did a very unscientific study, right? I took 20 Holstein calves and 28 beef on dairy calves of unknown origin, and I stuck them in the feedlot side by side, and I fed them the same, I implanted them the same, and I said, let's see what happens, right? And the beef on dairy grew faster, but they ate more. So no difference really in gain to feed efficiency, as we talk about that as pounds of feed versus pounds gain. And But they had bigger ribeye areas and a little bit more hot carcass weight at the end of that study. And so for us, that was the takeaway there was we could use these progeny from the dairy farms that have this beef cross in them and ultimately generate more food for human consumption from the same number of animals. And, you know, as much as we talk about food insecurity these days, to me, that was a real driving force in implementing beef on dairy research programs at Penn State.
Mm-hmm. Do you see any differences in health and immunity?
That's a great question. So we've switched gears after that initial test and did a series of studies where we picked up those baby beef on dairy calves at the dairy farm and took them the whole way through then. So we followed them from birth all the way through. And we never did that with the Holstein calves. Now, what I heard from our calf growers, though, where we bought baby calves from, is that these calves are more hardy. They're holding up better. They come onto grain faster. So I'll give you a little anecdote there. I had one of the calf growers call me, and he said, Dr. Felix, I know you want these calves weaned between 7 and 9 weeks of age. So we wean in 2-week cohorts. So you want these calves weaned between 7 and 9 weeks of age, 8 weeks average. And he said, but by God, they're 4 weeks in and they're already eating 3 pounds of calf starter. Can I just go ahead and wean them? I said, no, they're not a ruminant animal yet. Please keep them on the milk replacer. So from that standpoint, I do think that's where some of the benefits in health come from, is that we see these calves just getting a quicker start, if you will, in those calf systems.
You think that's just due to heterosis?
Maybe. I don't have a scientific answer yet for you on that, Scott. I do. Is it hybrid vigor? Is it the calves are bigger? We had one dairy farm call me. I really love the Charolais cross. They're absolutely, they were my favorite when they were on Sim Angus cows. They're still one of my favorites when they're on the dairy cow. They just grow like gangbusters. So I had these Charolais cross calves that I was putting in, and I only had one dairy that would do it for me at first, because everybody was like, oh, Charolais breeds big. Nobody had read the USDA mark size that Angus are the largest largest mature weight now. And so I said, just try it. And this one gal, she runs the dairy, and real gung-ho, Candace's daughter. And I said, Candace, you'll do this, right? She's like, sure, I'm not scared. So she put the Charolais semen in, and she called me and she said, Dr. Felix, I had a set of Charolais twins for you. She said, one was 153 pounds, one was 156. And I said, dear God, is the cow dead? And she said, no, she's in the milking parlor. She's doing just great. So you know, and I'm going to talk a little bit about this in my presentation today. We really focus on, or initially anyway, we really focus on calving ease and low birth weights and blah, blah, blah for these calves, right? And I really think the dairy cow's a lot tougher than we give her credit for. And that was an extreme example, but all that to say, these calves seem to come out and hit the ground ready to go.
I'm a big fan of the Charolais cross as well. And so out in the Central Valley of California, these calf ranches, they say some of the healthiest calves they've ever seen in the hutch, Scott, are actually Charolais, Holstein or Charolais Jersey crosses. And I think the Angus breed, even just straight beef Angus, we've seen an uptick of health issues. But I think when we put the Charolais on something like a Holstein or a Jersey, that heterosis factor, it impacts immunity as well. And they love those calves in the hutch because they're very hardy, like Dr. Felix said, and they hit the ground running. They eat a lot more in the hutch. So I think that's a really unique cross, and it's become a very popular cross across the country.
So what do you think's so special about the Charolais?
Well, I think
A lot of breeds out there. What about this one?
just from a health perspective, or all the way
Yeah,
through.
yeah.
So some of the early, if you go back and look at the very first beef on dairy work that was done in large volumes in the U.S., it was the Wolf Limousine group that now is tied in with Riverview Dairy. It was a limousine or Limflex on a Jersey or a Hojo cow. And those calves did well from a feedlot performance standpoint, very good from a red meat yield standpoint, but the limousine genetics actually pulled the marbling out of those. And Charolais, the right genetics on the Charolais side, we see really good marbling scores yet, especially we've had groups of Charolais Holstein and Charolais Jersey closeouts where they'll grade 15% prime. Now the problem is they don't have a black hide, so we lose the certified Angus beef. But I think they become very popular from a heat tolerance standpoint, a health standpoint. But I just kind of wanted to compliment what Dr. Felix said from a health standpoint. I think they're some of the healthiest calves these large calf ranches have seen in the hutch. So.
Well, and I think we need to add and be clear. So often we get focused on a singular breed. And in fact, that USDA project I mentioned, that was our whole, we're going to find the breed to Holsteins, right? That was our goal. The reality is it's not about the breed, it's about the sire. And early on in our beef on dairy systems, we did a really poor job promoting that as an industry on both sides of the industry. We talked a lot about breed. And while there's breed complementarity, these individual sires within a breed really, really are what make the difference.
And so do you see some similarities in the genomics between the sires within each breed that work on dairy?
So I don't think we have enough data to say that we see that yet, Scott. Bailey's paper on the genetic side that's going to be published this spring right now is one of the only ones that I know of that's focused on the genetics yet in these beef on dairy systems. But what we do see is a better selection based on those genomically enhanced EPDs that we use initially, right? And again, part of it's just the industries speak two different languages, and we're trying to tie together the dairy industry and the beef industry. And oh, by the way, at the end, we ultimately have to please the packer, right? And so we're spanning these multiple industries. And the dairy industry talks about predictive transmitting abilities, or PTAs, right? And that's their focus and their selection criteria for their bulls. And then the beef industry comes in and says, yes, but we talk about EPDs, expected progeny differences. And they're very, very different, the focus of the two of those. EPDs heavily focused on calving ease and marbling and carcass traits. PTAs heavily focused on milk production and cow longevity and health, right? We weren't speaking the same language initially. And if you've ever been in a foreign country, or you've ever been somewhere where you're the only one that speaks English, right, that's really challenging. And so getting those two industries to talk to each other ultimately means we need to educate across both segments how to have that conversation.
Yeah, and then the bull studs, I'm imagining we've got to get them involved and focusing on what works on dairy, and how well are they doing that today?
They are now heavily involved. In fact, if you look over the beef cattle industry, back when all this kicked off, right, and the shift from 2017 to 2018, 2017 being the devaluation of that Holstein cow, or of that Holstein bull calf, 2018 being the rise of beef on dairy, if you will. We went from just 2.5 million units of beef semen sold in 2017 to where last year the national NAAB said we sold 9.4 million units of domestic beef semen in the United States. And that just subsequently we've dropped the dairy semen sales about the same amount. So we're not all we're still a predominantly natural service from the beef cattle side, right? We didn't all of a sudden overnight say, hey, this AI thing's pretty good, let's put it all in beef cattle. We're really heavily focused on using that beef semen in the dairy herds now. And so I think you talk about how invested are the semen companies. They're heavily invested. They recognize that they're not going to pick up those sales from beef cattle producers, right? But they've got a market there with the dairy.
So Dr. Felix, the old adage was that when the semen companies came on board, it was to clean out all of their semen tanks, right, of the old, because the beef business doesn't use AI. But back to Scott's point, I think they've done a tremendous job of embracing this. So I think the first few years, it truly was, let's get all, here's some semen from a black-hided bull. It could have been, exactly. And now that's all gone. So I think they've really invested and embraced this. So maybe just for the listeners, Dr. Felix, you made reference to 2017. That was a pivotal year. And maybe for our friends on the dairy side, just to enlighten them, that basically what happened, Scott and Clay, in 2017 is a major packer, Tyson, said, hey, we've had it with these calf-fed Holsteins. They're too tall. They're dragging on the floor. So they put a height restriction on many of these in 2017. And that's what really tanked the market. And that probably was a really big impetus for the beef on dairy push after 2017. So I think it's important listeners understand what really started this phenomenon that we now know, the beef on dairy. So,
Terry, you'd mentioned that I think there were three aspects to the dissertation that your student did, and the first was the impact on the dairy industry. Can you talk a little bit about that?
Yeah, so what she did was she went around and farms in the Northeast, farms in the Midwest, and gathered up over 10,000 records from dairy. The dairy industry is absolutely brilliant, Scott. They have been tracking everything for a while because milk margins are tight, right? And so they have these beautiful technology systems where they know within a day if the dairy cow drops in milk production, for example. Very good record keeping. Okay, so Bailey went around and she got all those dairy herd records, and she said, okay, let's see if the cow has calved to a beef bull, or if the cow has calved to a specific breed of beef bull, if the cow is calved to a Holstein bull, how does that impact her gestation length, the number of calves that are born stillborn, any post-lactation health events we might think of, like mastitis or metritis or lameness, anything like that. And she summarized all those records, over 10,000 records she summarized, and said, what's the impact? And this is a spoiler alert for presentation I'm going to give today, so fortunately I don't think anybody will be listening to this early, but she said, what we found was that one of the greatest impacts was actually on gestation length. It didn't matter the breed of beef sire that we used. If we bred that cow to a beef sire, she had 2 days longer in her gestation than if we bred her to a Holstein sire. If you teased that out and looked at that across breeds, right, there's actually no difference in the Charolais, Dr. Johnson. So another reason to love the Charolais breed, right? But the Wagyu sires, those cows that were bred to Wagyu sires, held on to that calf an additional 8 days longer than those cows that were bred to a Holstein sire. You think about that and you're like, okay, well, Wagyu's a fairly small percentage. And it is. But back to Dr. Johnson's point, early on, everybody was like, oh, let's try this, let's try this, let's try this. And so we saw an uptick in everything. And what we really saw, if you tease out those semen sales, you really see a variation develop in how much semen's coming from all these different breeds, right? Well, what's a cattle feeder's number one enemy? Variation. Right? We are in the business of making commodity beef. It has to fit in a box so that it can ship to China and wherever else it's going, Canada, Mexico. And we add in all this variation from all these different breeds, because I'll tease the one dairy I worked with on the research project. She was like, "You got any Belgian blue? You got any Brangus semen? And we got some really cool looking hides. I mean, it's got one laying in my bedroom floor right now, right? Awesome stuff. But from a commodity beef standpoint, it still has to fit in the box. And I think that was a big problem. So gestation length was an issue.
Do we know why?
It's just the breeds, right? They're just different breeds. And those Wagyu calves, you talk about the hardiness of the Charolais calves. We had that discussion. The hardiness of the Charolais calves. Those Wagyu calves would come out at, 80 pounds, looking like a fawn. And when I did my master's work here, I was so broke up, I was working with sheep. Don't put that on the recording, right? I was working with sheep, and Dr. McDowell told me a lot of my sheep died when they came in. They had Homunculus contortus. It was a whole thing. But he said, Tara, don't don't upset yourself too much. Sheep are just looking for a way to die. They just took me out, right? I kind of felt that way with the Wagyu calves. Like the Wagyu calves were just looking for a way to die. And so maybe to preserve themselves, they stay in there an extra 8 days longer, right? I don't fully understand the mechanism of the why, Scott, on that one. It's just we know this within the breed. We know the breed has a longer gestation. The sire causes the Holstein cow to also have a longer gestation.
See, it's interesting because if you look at how genetic companies have selected for calving ease on the beef side, I don't know about on the dairy side, it's actually they use gestation length. So I would have thought the Wagyu having a smaller birth weight would actually have a shorter gestation length, but maybe there's something going on when you put that in a Holstein. That's really intriguing. I'm looking forward to seeing that data.
Well, when you look at how much of our domestic semen sales came from Wagyu historically, I mean, they're a very small portion of our domestic semen sales. And we have a little bit more imported semen from those calves, and we're growing that business now that dairies are interested, but it's still very much a niche market, right? It's not mainstream. And so you go back and you talk about, well, is it the breed or the sire? It's the selection pressure that we put on these individual breeds. We haven't put as much genetic selection pressure on the Charolais since the 1980s because Angus has been king, right? And so we've put a lot of emphasis on how do we make the best Angus genetics. And again, you go back to those mark data, and now the Angus are the heaviest mature weight breed by quite a bit. And because we've spent so much time focused on this genetic pool. You look at the dairy industry. The dairy industry's made tremendous genetic advancement, faster than the beef cattle industry. How has it done that? Through AI technology and genetic progress, right? Heavy genetic selection, so much so that the dairy industry is fairly inbred right now, right?
So Dr. Felix, what impact would that 8 extra days of gestation have to the dairy producer? That's got to impact something. I'm naive to the dairy side, but it's got to impact something negatively, I would think. Or
did I mention my PhD's in feedlot nutrition and management?
Maybe that's a question for Clay.
Well, so if the dairy producer's breeding beef on dairy, should they dry off at a later days carried calf then?
Yeah, so that was exactly what Dr. Bazile's conclusion was in her paper, Clay. You hit the nail right on the head. We have to manage that dry cow period differently, or we're going to give up milk production, right?
Interesting. Have they started to sort out this variation thing? I hadn't thought of that. Makes a lot of sense. Is that getting sorted out? Are we landing anywhere?
I think so, and here's why. So Dr. Johnson mentioned genetic companies fully on board now. For the first time ever last year, the NAAB I mentioned earlier, National Association of Animal Breeders, publishes the semen sales every year, right? And for the first time last year, they had a new category in their semen sales: heterospermic beef. Heterospermic beef, to the tune of 1.5 million straws. I told you we only bought 2.5 million domestic semen straws in 2017, right? Now this new category is added, and it is 1.5 million straws a year. Still doesn't top Angus, still doesn't beat Angus, but it's a heavy component of our beef semen sales now domestically. And I think that in and of itself is evidence of the emphasis that we're placing on this. The genetics companies, what they've done is they're targeting certain breed lines. When we first started increasing how many units of semen we were selling into dairies, we didn't have enough semen to fill the demand. That was the other part of the reason we're cleaning out tanks, right? The dairies want the semen, and we're not producing enough of it fast enough. I didn't know this, Clay, until I started. You know, dairy bulls produce more semen per ejaculate than beef bulls? I had no idea. And they're more fertile. So when we made this switch, the genetics companies didn't have enough bulls in the lineup. And so they started generating some crossbred bulls and some lines that they thought, based on their composition, and some, as Dr. Johnson mentioned, some of the early research done with the Limousine breed from Wolf Cattle Company, they started putting some of these things together and said, okay, maybe we don't need a specific breed. Maybe this genetic company needs this breed, maybe this, but maybe we need a composite bull. We need a composite bull that's going to bring all these things together, right? And so they all came up with their own lines, and then they put 2 or 3 of those bulls in a semen straw together and generate this heterospermic beef. So we're all that to say, your question was, do I think the variation is coming down? I think there's still some variation there. As we see this rise in heterospermic beef, we're using these composite lines, I think, to bring that variation down, to kind of funnel in and dial in on what is it that the packer ultimately wants and needs.
So explain the heterospermic beef again. This came up in your real science lecture. Yes.
Heterospermic beef. So there's a body of literature out there on the dairy side that says, every vaginal environment, every uterine environment is different, right? And so cows have a preference. I just did air quotes for those of you listening in your car. Cows have a preference for a certain bull's semen, right? Rather, their uterine environment has a preference for a certain bull's semen. And so the theory behind the heterospermic beef is, we can develop lines, and the genetics companies can market their own genetics, right? Homegrown genetics. But also, by putting a couple, 3 bulls in one straw, if the cow has a preference for any one bull, then we increase the fertility from that straw, because we've given the uterus that preference now. Now, what does that do to variation? Hopefully not too much, because these genetic lines are fairly similar that they're using, right? But to the point of fertility, hopefully it's increasing fertility. Now, haven't seen a ton of data on that yet, and of course no genetics company is going to share their data openly and publicly, right? That's their prerogative, but that's the idea and the science behind it, is that there is this preferential environment.
So what causes this preference? Is it a preference for a, don't know.
Again, my PhD's in nutrition, right? Reproductive biology. I got a C in reproductive biology. There's a reason I became a nutritionist.
Well, we'll have to find somebody that can answer that question. Have maybe a 4th podcast, Clay. Yeah. You mentioned in the dissertation the 3 parts. The second was the impact on feedlots. Can you talk a little bit about that?
Yeah. So the whole idea in this second chapter of Bailey's dissertation was going back to that USDA care grant. And again, that grant was written in 2019, right after we saw this big jump in semen sales for beef. And so the breed selection was all over the map. And the entire impetus of that grant was, is there a specific breed that we should be using? By the time we finished that grant, Scott, we were like, well, it's not about the breed, as we've mentioned. It's about the individual sire. But didn't know that going in, and USDA didn't know that either, so they still funded it. But it gave us a pretty clear picture that what we did in that study was we tried to pick sires within breed that ranked highly in characteristics that I felt were appropriate for feedlots. So yearling weight is one metric we use as it's a EPD metric that we have on our beef sires, those expected progeny differences, that helps us kind of tease out which sire might have better growth potential in their calves, right? We looked at things like carcass weight. At the end of the day, we are in the business of selling pounds out of the feedlot, right? Whether it's on a live weight or a carcass weight, we are in the business of selling pounds. And so those 2 criteria from an EPD selection standpoint factored heavily into my decision which bulls we're going to use, regardless of breed. Then I looked at things like marbling. when I was doing my work with the Holsteins, the number one complaint from the packer was this flat muscling that the Holstein had, right? Holsteins, you'll cut a ribeye out of a Holstein and you'd put it in front of a consumer and they'd swear it was a sirloin steak, right? This really flat angular muscle shape was a problem. So then I looked at ribeye area because we collect EPD, we evaluate EPDs for ribeye area as well. So are we going to get a larger muscle out of that calf? Because I selected sires, regardless of breed, on these terminal characteristics that I felt were critical for the feedlot, at the end of the day, unless they were Wagyu, not much difference, right? Because I was picking traits, not necessarily breeds. And I think that's what we have to get to in order for beef on dairy to work. We have to stay heavily focused, just as the dairy's heavily focused on PTAs and getting longevity and milk and health out of those dairy calves. We have to get them to focus just as heavily on the EPDs when they choose their bull sires, so that they stay focused on yearling weight, carcass weight, ribeye area, marbling score, those things that are really going to add value to that feedlot calf.
Makes sense, Brad. Same question. What kind of impact have you seen beef on dairy to the feedlots?
Oh, I think it's in the last couple of years, Scott, we've had low cattle numbers, right? So we're at a point of the cycle, and everybody thinks heifer replacement should be going back into the herd. But if you look at heifer slaughter data, it still hasn't happened. So I think this has been a blessing from a fed cattle standpoint, that roughly ballpark 20% of the cattle, let's say, have some dairy influence that are going in. And so it's really helped fill that gap on cattle numbers. And so it's interesting. The packers would tell you, oh, it's not 20%. And I think a lot of it is because the packers now can't tell the difference between a really good beef on dairy cross and a native beef. And so what's interesting is, as Dr. Felix said, in the early days, we were trying to get one step above 100% dairy influenced animal, either a calf-fed Holstein or the Jersey bull calves had no value, right? I mean, they literally euthanized a lot of them. Now what's interesting is the packers have embraced this to the point they want us to make them as good day in and day out as 100% beef, and in many respects, we're getting very close to that. So it's been a huge deal on the feedlot side, even though it is only 20%. It's filled a gap where we were at a low point of the cattle cycle, and it allowed us to bring in some really high quality cattle. So
yeah, so we had a shortage of native cattle, filled a gap. So that was a short-term benefit. What's it look like long-term? Is it still a benefit to the industry as a whole?
I think absolutely. I've had several people ask me this. Dr. Johnson, why are you spending so much time on 15 to 20% of the cattle? And one thing and Dr. Felix did a great job of talking about all the different segments. We got the genetic companies involved now, and they got all the tools on the genomic side to make huge progress in a very short period of time, right? I take what we learn on the beef on dairy front. Let's try to make our native beef population that much better. Dr. Felix just got done saying we hardly do artificial insemination on the beef side. We might inseminate our heifers, but we're for sure not going to do it on the mature cows. Look what they do in Brazil. Every animal down there gets a straw of semen almost every year. And I tell people we've learned so much in 5 to 7 years on the beef on dairy at the end product side. Let's make our general beef population that much better. That's why I'm kind of still riding this horse, is to challenge our beef producers to get better with what we've learned on the beef on dairy space. So.
I think that's a great point, Brad. The last USDA grant that I submitted, I got that comment back. Well, why do this? It's only 20% of the beef cattle that are on feed every year. Well, so were Holsteins. Holsteins were not replacing any of the native beef cattle, right? But by bringing in these genetics and improving our genetic potential, we are creating more beef for each animal that we send through. So that 20% with beef on dairy actually recognizes far more beef product at the end than that 20% Holstein did. And I think that's important as well.
And is that beef being consumed differently? No, I'd always assume maybe a lot of the Holsteins went into the ground beef. And
Oh, Holstein beef is a phenomenal quality. In fact, JBS had a box just for commodity Holstein beef, and a lot of it went into high-end restaurants. It was their 5-star product, and a lot of it went to high-end restaurants in New York City because the ribeyes were smaller, so you could cut the steaks thicker, and so you couldn't screw up the cooking quite as bad as you can when you've got to shave a 16-inch ribeye down to a half an inch, right?
So JBS, it would have 2 major packing plants yet that were built to kill straight calf-head Holsteins, one in Green Bay and one in Tolleson, Arizona, right outside of Phoenix. And to this day, the Tolleson plant, they still want to kill straight Holstein steers. That's what they want to harvest. And they've really struggled finding enough high-quality calf-head Holsteins because of the beef on dairy. But they've been somewhat reluctant because they had a couple branded programs specifically, as Tara said, for the Holstein deal, and they've struggled to adapt to the beef on dairy. So the dairy influenced animal, either be a calf fed Holstein or a beef on dairy, it's noted for very high quality, high palatability beef. So.
Well, and not only that, but in Pennsylvania, we have a pretty big veal grower, and even the veal growers saying that now. They can't get Holstein bull calves anymore, or enough of them, and they don't necessarily like the beef on dairy for the veal product. It cuts a little bit darker, it grows a little bit different, and so it doesn't make, even though we don't eat that much veal in the United States, it doesn't make the veal product that the consumer is used to. And if they can't get the Holstein bull calves, by God, now they're paying $400 or $500 a crack for them. And when you look at the margins on veal, boy, it's challenging right now.
So, what are the challenges that still exist with beef on dairy?
Oh, therein is the $1 million question, right? I think we have to get past this focus of it's only 20% of the fed beef supply. It's still 20% of the fed beef supply, right? And as Brad mentioned, I don't think it's going away. Like, we've kind of stumbled on a pretty good thing because there were a lot of factors that we've already discussed that made us have to accept it. But we're making pretty rapid progress. If you just look at the publications that have come out in the last 6-7 years regarding beef on dairy, there has been a flurry of scientific data that have supported the growth of this industry. I do still think health is a big deal. Maybe it's better than it was with Holsteins, but let's face it, we've always sort of had a challenge with this image of raising baby calves in hutches, right? And we're still going to face that, even if they're beef cross calves. So I think health is a challenge. I do think we need to figure out there seems to be an issue with liver abscesses in some production systems, and it's not clear what that issue is yet or what's driving that issue yet. And so I do think we need to dial in and figure out, get a better handle on the causative mechanisms for these liver abscesses. We don't even know anymore where they're even coming from. We used to say, oh, it's acidosis, acidosis, acidosis. Now we're like, could be the hindgut though. Salmonella, that's a hindgut issue. We don't have a clue right now. And so I think that's going to be a big one. Depending on which paper you read and the year that it came out, it's either a $60 million issue or it's a $400 million issue, right? And regardless of which hand you're in, that's still a really big issue to a margin-based industry, to a commodity industry. So I think that's a problem. We will always, in the cattle industry, one of our biggest challenges has always and continues to be bovine respiratory disease. That is our number one challenge in feedlot systems. It's our number one challenge in baby calf systems. And so as we dial in on these, I started with this overarching health issue. It's bovine respiratory disease and it's liver abscesses. Those are our top two biggest economic challenges in in the cattle industry, whether it's dairy or whether it's beef. And I think we're going to have to continue to chase those down as we stay focused on the genetic progress, as we create more beef from each animal. We're going to have to continue to chase down these issues with health.
Do you know, are these calves, are they receiving enough colostrum at birth?
Great question. Initially, right? This was my big push to the dairy. Not necessarily which semen straw do you put in, but by God, just give them colostrum. We did a study with one of my undergraduate students. We needed a fun little undergraduate project, and we had all these baby calves lined up anyway. So we said, take the Brix refractometer out and poke a hole in them, get some blood from them, and let's test serum total protein levels. So as these calves were coming in, she did just that, and it's a pretty quick and dirty on-farm test to use the Brix to get that done. And what we found was, and this is not published anywhere, so don't try and look it up. It was just an interesting observation. Those calves that had successful transfer of passive immunity as determined by their serum total protein at less than a couple days of age, it was when we brought them in from the dairies off the truck, they had more pounds, so they grew more during the first 9 months of their life. They were heavier at 9 months of age than those calves that didn't have successful transfer of passive immunity, that had failure to transfer that passive immunity. So I do think that colostrum plays a big role in this as we go from birth all the way through life. Those data are really difficult to collect. Dr. Pedro Carballo is a former PhD student of mine. He's at Colorado State right now, and he's working on a big colostrum grant to try and tease out some of those issues, Clay, because it is critically important.
Terry, even in addition to the passive immunity, there's all these bioreactive components of colostrum, right? There's growth factors like IGF-1 and all these other good things. I think there's so much value of trying to get the best possible colostrum produced on day one from the dairy cow perspective. But there's been a lot of interest recently of what they call post-day one feeding of dried bovine colostrum in these large calf ranches out through 10 or 14 days. They've seen phenomenal results on performance, also less liver abscesses, better health. So it's not just an immune function at that point. I think there's so many growth factors that could come through that during that dry period of the cow, trying to get the best possible quality of colostrum produced to get that calf off to a great start, I think is paramount for this beef on dairy business.
The serum total protein's easy to measure, right? We can get that easily.
Oh, absolutely. And that's the main function of colostrum, right? I mean, But
to your point, that prolonged colostrum feeding, I mean, we're not measuring serum total protein anymore. Gut closures happen. We're not getting that passive transfer anymore. But these other compounds, absolutely, 100%. Like what's going on there? It definite benefits.
Yeah, Brad, we talked a little bit about the impact on the dairy. We talked about the impact on feedlots. What about the cow-calf operation? What, if any, impact has it had on those folks?
Well, it's been a political deal for many of those. There's rumors of fistfights in the hallway at NCBA meetings between, traditional cow-calf producers and genetic companies, because why are you promoting beef semen to dairy production? But again, I think that's very short-sighted. We're in this business together. I go back to what I said earlier. I think the cow-calf producers, just our discussion we had on colostrum, they could benefit so much if they understood the biology of colostrum formation during their dry period. And I mean, again, let's use what we're learning from a total confinement system of a dairy-influenced calf and try to apply it to get a more efficient, heavier calf at weaning on the cow-calf side. But I think obviously the cow-calf production segment has benefited the last couple years just from the value of feeder calves, right? Just like the dairy producers are selling $1,000 day-old calf, these cow-calf producers are now selling $1,600, $1,800 wean calves, so they benefited from the short cycle of cattle as well. But I think it was kind of cantankerous early on, because even many of the breed associations felt on the traditional beef side that, yeah, our semen's being used on the dairy, but we're not selling any more range bulls to go to Montana or Western Dakotas, right? So why is that benefiting our breed? And again, I think we got to be holistic and think of this as we're in the food production system, right? And we're all in this together. So again, hopefully the cow-calf producers realize there's going to be technology and genomic solutions that come out of this that will benefit them as well. And I think the whole colostrum deal, if we just focus on one thing like colostrum for the cow-calf producer, that could have huge impact on the health of those calves and the vigor and weaning weight. And I think we have so much to learn on that front, Scott. So
Makes a lot of sense. Yeah, for sure.
God, I've taken heat for 9 years in Pennsylvania, right? Because I did Holsteins first and then beef on dairy. And I still have to serve the cow-calf producers in the state in my extension role. And they're always, Dr. Felix, you're trying to put us out of business. You're trying to put us out of business. And I said, guys, the reality is, if you look at the National Beef Quality Audit data, we had 20% dairy influence when they were Holstein. We have 20% dairy influence now that they're crossbreds, right? We're not changing how many calves come from the dairy industry every year. We still have 9.4 million dairy cows, and that number's not going anywhere.
And
right?
92 million total cattle. So we've maintained 10% dairy cattle forever, right? So you're exactly right. That has not changed. So
what we're doing is we're increasing the amount of beef. Well, what does that do for us? Well, look at our export markets in recent years, right? We have the opportunity to be the global supplier of beef if we dial in and stay focused. And the U.S. has always had that advantage from a beef production standpoint, right? Dr. Johnson mentioned Brazil, right? And I love going down to Brazil. When they started growing their feedlot systems, they would call me, and yes, every time. It's a great culture down there, tons of fun, and really folks that are excited to use technologies, right? But they have twice as many cows as we have and produce the same amount of beef. That's a highly inefficient system from a production efficiency standpoint. And so I think the U.S. has always been an advantage from how focused on efficiency we are, how focused we are on getting more pounds of meat from a single animal. And I think for dairy producers and cow-calf producers alike to understand that part of it, to understand, yeah, we're all in this together. There are going to be benefits that come out, just as Brad said, for the cow-calf side. But the reality is we're not changing the number of progeny that are coming from the dairy side. We're just making them better.
Yep, makes perfect sense. As we get ready to close out, there were 3 chapters. Can you talk a little bit about chapter 3?
Look, I've come to appreciate and understand the dairy side. The most interesting thing, I think, my biggest takeaway from chapter 3 was 50% of that genetic potential still comes from the Holstein. And Brad mentioned things like growth factors. There are still components of that dairy cow's genetics that are driving the outcomes in these beef on dairy crosses. And we have made a lot of progress focusing on the sire. And if we look across agricultural systems, whether it's swine, whether it's cattle, whatever, that's where we have the heaviest influence, because we can put one sire on a lot of cows, right? But we can't forget that 50% of those genetics still come from the Holstein. And as we all learned way back in ANSI 100, right, phenotype equals genotype plus environment. And how that Holstein genetic component is going to factor in here, I think, is something we're going to see more of in the future.
Yeah, interesting. Folks, this has been a fascinating conversation. I've enjoyed it. Time has flown by. As we get ready to close out, what I'd like you to do is ask each of you just to kind of give us a couple takeaways that the audience can take home with them. And Clay, if you don't mind, I'd like to start with you.
Our last call question is sponsored by AminoSure XM Precision Release Methionine, the next generation in amino acid balancing. With AminoSure XM, you can save up to 5 cents per cow per day on your methionine investment. Try it today and receive an additional 2.5 cents per cow per day savings with Balchem's limited time rebate offer. Contact your Balchem representative to learn more.
Yeah, so one of the big ones from my standpoint, which I was unaware of, was this difference in gestation length. So that happens a little bit within the dairy breed too. So brown Swiss they have a longer gestation length than Holsteins do. So that's something that people need to take that into account when they dry their cows off. That they should wait a few more days to dry off these cows that are bred to beef on dairy.
Yeah. Thanks, Clay. Dr. Johnson, any key learnings or key things you'd like to share with the audience?
Well, the one thing that Dr. Felix just ended with about let's not forget about the maternal side, and she was talking specifically about Holsteins, but I've been on a large Jersey dairy, they talk about the California Jerseys, and then I've seen some Jersey cows in Colorado, and the phenomenal difference in degree of muscling between the California Jerseys and the Colorado Jerseys. And that gets transferred, right? And so I got closeout data from Colorado. These were Angus Jerseys. Now there may be, for the most part, straight Jersey genetics, but the difference in muscling of those Jersey cows in Colorado resulted in phenomenally better progeny from a beef production standpoint. So I think what Dr. Felix ended with, we talk all about the sire and the beef sire, and I'm going to show a picture at the end of my talk this afternoon. Even though genetically these dairy cows, albeit Holsteins or Jerseys, are really pretty identical, back to what phenotype is versus genotype, there's still a lot of variation even in these Holstein cows for stature and muscle, right? So maybe the dairy producers can do a good job of selecting without giving up milk production, because I know that's what they're in it for, but maybe they can find the right mama cow that has a little more muscle that even helps us beef on dairy more. So that'd be one of my takeaways. So
Interesting stuff. Dr. Felix, what's your final comments?
At the end of the day, it's about feeding people, right? And at the end of the day, I hope Brad's right. I hope that all that we've learned about genetics by our use of beef on dairy these last years trickles down to the cow-calf sector, and we end up with more beef from less animals, because from a food security standpoint, that's critical, right? What happens when populations become more affluent? They choose animal protein because they recognize the benefits of that. And so I think this has been a really great outcome for beef on dairy. And, I hesitate to use the word sustainability, and I tried not to in most of this pubcast, but the reality is that's true sustainability right there, making more out of the same number of calves. And I think we're doing that. And to me, that's the number one thing to be proud of through all of this.
Yeah, great comments. Tara, Brad, you guys have been great guests. I've really enjoyed this conversation. To our loyal audience, I hope you've enjoyed this as much as I have. And if you'd like more, we're going to be recording Dr. Felix's presentation, and we'll have it up on balchem.com/real science. So you can go there and get a little more in-depth presentation on this topic. To our loyal listeners, hope you learned something. Hope you had some fun. We hope to see you next time here at the Real Science Exchange, where it's always happy hour and you're always among friends.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email to anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars continues with ruminant-focused topics on the first Tuesday of every month, monogastric-focused topics on the second Tuesday of each month, and quarterly topics for the companion animal segment. Visit balchem.com/realscience to see the latest schedule and to register for upcoming webinars.